In this lecture, we will be studying about simplification of context-free grammar. So in context-free grammar, sometimes all the production rules and symbols are not needed for the derivation of strings. Besides this, there may also be some null productions and unit productions. Elimination of these productions and symbols is called simplification of context-free grammar. So we have studied about context-free grammars, and in those grammars, sometimes all the production rules and symbols are not needed for derivation of strings. So we can eliminate those unnecessary productions and symbols, and that is called as simplification of context-free grammar. Also, there may be some null productions and unit productions. Now, the meaning of these null productions and unit productions, I will explain it to you in the coming lectures, so don't worry about it. And so, elimination of these useless productions and symbols is called simplification of the context-free grammar. And the simplification consists of the following steps. It has mainly three steps. One is the reduction of CFG, which we will be studying in this lecture, and then we have the removal of unit productions, and then we have the removal of null productions. So these two we will be discussing in the coming lecture. So in this lecture we will be studying about the reduction of the context-free grammar. Okay, so let us see how we can do this reduction of context-free grammar. So reduction of CFG, it is done in two phases. So first we'll discuss the phase 1, then we'll go to the phase number 2. So in phase 1, it is the derivation of an equivalent grammar G dash from the context-free grammar G such that each variable derives some terminal strings. So the procedure to do that is, step number 1, include all symbols W1 that derives some terminal and initialize I equal to 1. So we have our context-free grammar G, and from that we will make a set of symbols which we will call W1 that will contain the symbols that can derive some terminal symbols. So those we will keep in our set W1, and then we initialize I equal to 1. Okay, and then in step number 2, we include the symbols Wi plus 1 that derives Wi. So in the previous step we had the set of symbols that derive the terminal symbols, and in the next step we will make another set of symbols which can derive the symbols that were present in the set of the previous step. Alright, and then we will increment I and repeat step 2 until Wi plus 1 equal to Wi. So we will increment I and we will repeat this step number 2 until we reach a stage in which the two consecutive steps produce the same kind of sets. If the elements of the sets in two consecutive steps are the same, then we stop the process, and then we include all production rules that have Wi in it. So after getting this final set Wi, from there we will include the production rules, all of which contains the symbols in the set Wi. So that is phase number 1. So don't worry, even if it sounds a little confusing, it will become very clear when we take the example. Okay, so now let's go to phase number 2. So phase number 2 says derivation of an equivalent grammar G double dash from the CFG G dash such that each symbol appears in a sentential form. So we have already obtained the grammar G dash using our phase number 1 from the original grammar G, and from this G dash that we have obtained in phase number 1, we have to derive another equivalent grammar G double dash such that each symbol appears in a sentential form. Now how do we do this? Let's see the derivation procedure. Step number 1. Include the start symbol in Y1 and initialize I equal to 1. So we form a set which we will call Y1, and in this Y1 we will include the start symbol of our grammar, and then we initialize I equal to 1. And then step number 2 says include all symbols Yi plus 1 that can be derived from Yi and include all production rules that have been applied. So just like we did in phase number 1, even in this one we see that in Y1 we have our start symbol, and then in the next step we will include all the symbols in the set of the next step that can be derived from the symbols in the set of the previous step. So here our previous step contains the set containing the start symbol. So in the next step you will include all the symbols that can be derived from the start symbol. That will be your Yi plus 1. and then increment I and repeat step 2 until yi plus 1 equal to yi. So you will continue doing this. You will continue including the symbols that can be derived from the symbols in the previous set of the previous step and make new sets until you reach a stage where two consecutive stages or steps produces two sets of containing the same symbols. At that time you will stop the procedure and we will include the productions that we obtained in the last set yi. Okay, so that is the phase number 2, and following this phase 1 and phase 2 we can obtain the reduced context-free grammar. Alright, so now we will see an example to understand it in a better way. So here we have an example which says find a reduced grammar equivalent to the grammar G having production rules, this one. So we are given a grammar G and we have a production rule which says S gives A, C and B, and A gives A, C gives C and B, C, and E gives A and E. So here the start symbol is S and the non-terminal symbols are A, C and B, and the terminal symbols are small a, C and small e. So we have to find a reduced grammar for this. So we will follow those two phases which we have studied in the beginning. So let's proceed with phase number 1. So in doing phase number 1, we have to first find out what are our terminal symbols. So as I already mentioned, our terminal symbols are small a, small c and small e. These are our terminal symbols. And now we have to make a set W1 in which I will include all the symbols that can derive the terminal symbols. So what are the symbols that can derive the terminal symbols? Let's see. So here we see that S does not derive any terminal symbol, so we can leave S, and we see that A derives the terminal symbol small a, so I will include A in this, and then C also derives a terminal symbol, so C will be included, and E also derives a terminal symbol small e and also small a, so E will also be included. So I have my set W1. Now I have to make a next set W2 in which I have to include all the symbols that can derive the symbols present in the set W1. So in W2 I have to include the symbols that can be derived from the set W1. So what are they? A, C and E will all obviously be there, and let's see if there are any others. Let's check the start symbol S. So we see that the start symbol S can derive A, C, and AC is present in the set W1. So we have to include the start symbol. So ACE, let me write them as they are, and then we have to include the start symbol S. Okay, now let's do the same thing again. W3 we will do the same thing. We have the symbols A, C, E and S, and we have to include all the symbols that can derive A, C, E and S, and A, C, E and S can be derived only from S, A, C and E. So it is the same thing, A, C, E and S. So we find that in two consecutive steps, W2 and W3, we are getting the same kind of symbols in the set. So we can stop this procedure. So this is the final set W3 that we have obtained. Now we have to see how can we write our grammar. So our grammar G dash can be written as, what are the non-terminal symbols? A, C, E and S. Okay, these are our non-terminal symbols. And what are our terminal symbols? Here the terminal symbols that we will have are A, because A derives A, and then C derives small c. Okay, and E derives, what does E derive? E derives small e. So this will be our terminal symbols. S does not derive any terminal symbol. And then P is the production rule which we will write now, and after that we have S, which is the start symbol. Okay, and then let us define the production rule. How do we define it? Production rule will be given like this. Let us start with the start symbol S. Here we have S, and here we did not have B in any of our sets over here, so B will not be included. We will only use the production rule which says S gives AC. And then we have A. For what does A give? A gives small a, and then we also have C, which gives small c, and then we have E, which gives small a, and also e. Okay, so this is the production rule for our grammar G dash, which we have obtained from phase number 1. Now let us proceed to phase number 2. In phase number 2, we have to look at the grammar G dash that we have produced. So our first step was to include a set y1 in which we will include only the start symbol, which is s. Okay, and then in y2 we will include all the symbols that can be derived from the start symbol s. So what are the symbols that can be derived from the start symbol s? We see that s can derive a, c. So a and c also should be included. So s is there, and then a, and then c. Okay, that is from this production rule. And then in the next step, which is y3, we have to include all the symbols that can be derived from these symbols in the set y2. And what are they? We see that s derives ac, ac is already present, and we have a here, and we see that a derives a. Okay, so s is there, a is there, and c is there as they are. Now what are the new ones we have to include? A derives small a, so I derive small a, and we have c. And what does c derive? C derives small c. Okay, so these are the things we have to include. And if we do one more step, y4, we'll see that there will be no change. What are the symbols that can be derived from these symbols? They are only s, a, c, small a, and small c. So these are the only symbols that can be derived. So we get these symbols, and we see that in step y3 and y4 we are getting the same symbols in both the sets y3 and y4. So we can stop the procedure. And now we have to define our grammar G double dash. Non-terminal symbols are A, C, and S. This one. See, we see that we have A, C, and S here. And then what is our terminal symbols? Only A and C are the terminal symbols. And what is the production rule? We'll call it P, which we will define. And then we have S as our start symbol. Okay, so this is the grammar G double dash that we have. Now we have to define the production rule P. So in order to define the production rule P, we have to see what are the symbols that we have. We have A, C, and S. Now let us start with the start symbol S. S, what does it derive? S derives A and C. A and C, that is all what we used. And then what is the next one? A. What does A derives? A derives small a. And then we have C. What does C derive? C derives small c. So this is the new production rule for our grammar G double dash. So now we have the reduced grammar G double dash, which is a reduced form of the grammar G which was given. So if you notice, you see that in the original grammar this was a production rule. It was a long one. Here we also had E, and we also saw that C was giving C and also BC, and S was giving AC and also B. But if you look at the reduced grammar that we have, we see that S gives only AC, A gives A, and C gives only small c, and E is no longer there. So this is a simplified and reduced form of the given context-free grammar. So this is the way you reduce the CFG. So I hope that was clear to you. And in the next lecture, we will be studying about the removal of unit productions, followed by the removal of null productions. So thank you for watching this one, and see you.